Hi, welcome to Sachin Study Tech. Today topic is knapsack problem. Knapsack problem is an example of the combinational optimization problem. This problem also commonly known as rucksack problem. The name of the problem is defined from the maximization problem. So what is meant by maximization? So here you can see given a bag with maximum weight of capacity of W and a set of items each having weight and associated with some values. Decide the number of each items to take in a collection such that the total weight is less than the capacity of the bag and total value is maximized. So this is the maximization problem. So what is meant by maximization? Here the knapsack or bag, it can give the bag capacity W. So you can choose some items. What are the items is there? You can choose those items. Then the total weight is less than the capacity and total value is maximized. What are the object you are selected? You can get the maximum profit. So two types of knapsack problems. Types of knapsack problems here: fractional knapsack problem and 0-1 knapsack problem. What is fractional knapsack problem? For example, you can have the some objects, that objects having some weight. So the weight is divisible. For example, here some two objects is there, object 1 and object 2. Object 1 having the weight is 5, object 2 having the weight is 3. So you can consider this is the kgs or anything here. For example, I am considered this is the 5 kgs of onion, 3 kgs of potatoes. So it is divisible. You can take 1 kg or 2 kg based on the remaining capacity of the bag. So that is the fractional knapsack problem. So the fractional knapsack problem x value is 0 less than or equal to x less than or equal to 1. X value may be 0 or x value may be 1 or x value may be fractions. So you can take the in between 0 to 1. That is the fractional knapsack problem. Here it is 0-1 knapsack problem. So you cannot that items are not divisible. Either you can take the complete item or you can ignore that object. That is the 0-1. So 0 means you cannot consider, you cannot select that particular object. Okay, the x value is 0. 1 means you can select or you can choose that particular object. The x value is 1. So here 0 or 1. For example, the items are fridge, for example washing machine, like for example scanner and printer. These are the some objects. That objects you can carry that complete object or you can ignore that object. You cannot take the fractions. That's why the x value is either 0 or 1. 0 means you cannot consider, you cannot choose that particular object. 1 means you can choose, you can take that object, you can store that object into the bag. So the x value is 1. So xa is belongs to 0 or 1. So what is the maximization or minimization problem here? For example, the constraint, what is the constraint here? For example, summation of WA, weight of the each object, into XI, that is less than or equal to some capacity. For example, here the capacity of the bag is M. M is the capacity of the bag. What is I? I is 1 less than or equal to I less than or equal to some N. So that number of objects, 1 to N number of objects is there. You can collect that object WI into XI less than or equal to capacity of the bag. M is the capacity of the bag. So this is the constraint. You can choose the items based on this constraint. And what is the object 2? So object 2 is maximization of the profit. You can take the maximum profit, that is PI, each and every object having some profit, PI into XI. So it is a maximum profit. You can get the maximum profit. How you can get the maximum profit? So you can select the items based on that choosing items. You can get the more profit. So here I is 1 less than or equal to I less than or equal to n. What is xa? So x is 1 less than or 0 less than or equal to 0 less than or equal to x less than or equal to 1. So in fractional you can take 0 or 1 or any fractions. For example, you can take the 0-1 knapsack problem. You can take only 0 or 1. That x value may be 0 or 1. So you can consider that particular object. So the x value is 1. If you cannot consider, you cannot store that particular object into the bag, that is called as a 0. X value is 0. Now you can see the one example. Now in this class you can discuss about the fractional knapsack problem. Later class you can discuss 0-1 knapsack problem by using dynamic programming. But here the fractional knapsack problem you can discuss now by using greedy method. So this is the example. Find an optimal solution to the knapsack. Instance is number of objects is 7 objects is there. So capacity of the bag is 15. So here the 7 profits is there. So 7 weights is there. So you can note down here. These are the objects. 7 objects is there. 1 to 7. These are the profits. So this is the weight. So you can see what's the bag capacity. Bag capacity is 15. For example, this is a bag. So this is a bag. The bag capacity is 15. So the bag capacity is 15. For example, here it can consider as a weight is considered as a, for example, cases. So you can consider this is the 15 cases. So you can store items up to the 15 cases less than or equal to 15. So this is the constraint. For example, you can see what are the 7 objects is there. What is the total weight of the 7 objects? Here you can see 2 plus 3, 5, 10, 17, 18, 22, 23. So total is 23 kgs. But here the capacity of the bag is 15. So that is the problem. You can choose the object. Which object you can choose, you can get the maximum profit. So that is the problem. If it is all object weights are less than or equal to 15, there is no problem. You can choose all the what are the objects is there. You can collect all the objects and then you can get the total profit. But this is a problem. So all object weights are, for example, here more than the bag capacity, then the problem will start. So you can discuss this problem will solve by using greedy method. You know already what is the greedy method. Okay, previous videos you can explain, you can watch it. For example, so how you can choose that object. So if which object we can take, which object you can fill in this bag, you can get the maximum profit. For example, here you can see the profit is maximum profit is 18. But here in 4 kgs you can get the 18. But what is the 1 kg profit? So first you can find out the maximum profit. Each and every item here you can take P by W. So here the profit object 1 profit is 10. Here the weight is 2. So 10 by 2. 10 by 2 is 5. Okay, 1 kg. If you can consider 1 kg weight that particular object, then you can get the 5 profit points. For example, here also you can like that. So 5 by 3, that is 1.6. Here the 15 by 5, that is the 3. Here the 7 by 7, that is 1. Here the 6 by 1, that is 6. Here the 18 by 4, that is 4.5. So here the 3 by 1, that is 3. So these are the profits. For example, each and every object profit of, for example, now we can consider the x value here. For example, which object having the more profit? In this case, here you can see. So 6 is the maximum profit. So we can choose that particular object. So object 5, how many kgs is there? Only 1. Then total bag capacity is 15. So you can consider weight is 1. So 15 minus 1. So remaining bag capacity is 14. So x value is, you can carry, you can choose that complete object, then the x value is 1. So next highest profit is 5. So the weight is, object 1 weight is 2. So here the 14, the bag capacity is 14. So you can consider total weight 14 minus weight of the first object 2. So remaining capacity is 12. Here also you can consider the complete object. So the x value is 1. Now next highest is 4.5. So here the weight is 4. Sixth object weight is 4. So here 4 less than or equal to 12. Okay, condition is true. Then you can choose that particular object. 12 minus 4. The remaining back capacity is 8. So here it is x value is 1. Next highest is 3. Here also 3. So either you can choose any one of the object. Both are same profit. So here you can consider the 5 or 1. So 5 means if you can choose that 5 weight, so they can get the 15. Here you can choose one object, you can get the profit is 3. So both are same. You can consider any one. For example, here 8 minus, so it is the weight is object 3 weight is 5. So 8 minus 5, that is remaining capacity is 3. So you can choose the complete object here. X value is 1. Now again you can see here the 7th object, that object is next maximum profit. So here object weight is 1. So 1 less than or equal to 3. Remaining capacity is 3. So you can choose that object. 3 minus 1. Remaining is 2. So here also you can take the complete object. That's why x value is 1. 1 means you can take that complete object. 1 means, for example, so what is the remaining capacity back is 2. Now here the next maximum profit is 1.6. Next maximum profit 1.6, but weight is 3, but remaining capacity is 2. So 3 less than or equal to 2. The condition is fail. So you can take the fractions also. You can take the fractions. So out of 3, you can take only 2 cases. So because the remaining back capacity is only 2. So that's why 2 minus 2 is remaining capacity of the bag is 0. So you can take only 2 by third part. So here you can take the 2 kgs out of 3. So the x value may be a fractions. So it is fractional knapsack problem. So that's why you can take the fractions also. That is 2 by 3 part. So remaining is here the profit is 1, but there is no space in that bag. So x value is 0. Cannot choose that particular object. So this is the problem. So what is the total weight here? What are the objects you can consider, you can store, you can fill in that bag? So Wi into Xi less than or equal to capacity of the bag is M. So Wi into Xi, I value 1 less than or equal to, I value is 1 less than or equal to I less than or equal to N. You can see here Wi into Xi, that is equal to Wi. So what is the first weight is, here the weight is 2. 2 into what is the x value? X value is 1. 2 into 1 plus here it is next weight is 3. 3 into what is the xi value? 2 by 3. 2 by 3 here plus here the next weight is 5. 5 into what is the x value? X value is 1. That means you can consider that particular object. You can store that particular object into the bag. Here it is 0. So 7 into xi value is 0. 7 into 0, that is 0 plus here the weight is 1. X value is 1. 1 into 1, 1 plus, and here also can take the complete object. Here 4. So 4 into 1 plus here it is next weight is 7th object weight is 1. So 1 into x value is 1. 1 into 1. So what is the total value here? We can see already. So that is 15. So here it is 15 less than or equal to what is the back capacity is 15. So it satisfies this constraint. This subset is, this problem is satisfied this constraint. So what is the maximum profit you can get? So that is pi into xi, pi into xi, that is equal to, what is pi? Here it is 10 into xi value is 1, 10 into 1 10, plus here it is profit 5, but you can take 2 x value is 2 by 3, 5 into 2 by 3, plus here the next one is 15 into 1, plus here it is the profit is 7, but x value can 0, that means you cannot consider this object, that's why cannot get this profit. So that is, here profit is 0. Next one is profit is 6 into xi value, plus 18 into 1, plus here it is 3 into 1. So the total value is 55.3. So you can get the 55.3. So this is the maximum profit. If you can choose, for example, randomly can choose any objects, you can fill that bag by you can choose this object, you can fill that bag, but you cannot get the maximum profit. So you can follow the greedy method, then you can get the maximum profit. Here the maximum profit is 55.3. So this is the maximization problem. So thank you for watching this video.